Find the volume of the solid obtained by rotating the region bounded by y equal x squared and y equal 1 about y equal 5. So the first thing we're going to want to do is sketch our region so we can see what's going on. So let's do that. We see that we have y equals x squared. That's just our basic parabola. And then we also have y equal 1. So that's just a horizontal line at y equal 1. Now we're rotating this around y equal 5. So let's go ahead and make our little axis of rotation up here at y equal 5. So let's look at what a representative slice would be like. If we sliced it here, we see that we would have, as we rotate this region around, we would generate washers here as we look at representative slices. This would be the piece that would be in the washer, and this would be the hole in the middle. We will need to know our values where these curves intersect, and that's just simply where they equal each other. So it's where x squared equal 1. So we're going to integrate from -1 to 1, and we can see that we have, if we looked at this big radius, so essentially when we're doing the washer method, we want to have this big radius, the whole thing, that would be like the disc, and then we want to subtract off this little radius. I'm going to call that little r the radius of the hole. So as we first of all look for big R here, we see that that's this distance right here. And what it is it's 5 up here at y equal 5 minus this distance right here from the x-axis up to the function. Well, that's just the y value of this graph, so that's just y equals x squared. So when I want to put the radius here, it's going to be pi, the big radius, it's going to be 5 minus x squared, and then because it's r squared, I need to square that whole thing. So the picture told me the story. I said, how can I find the length of this big R? And I looked at that and saw that it was all of the way here 5 minus the function value or the y value here to leave me that length. Now we need the radius of the hole, and when we look at that, we see that the hole goes from here to here, and that's not going to change wherever we make our slice because this is constant at y equal 1 and this stays at y equal 5. So it is that distance there, and the difference from 5 to 1 of course is going to be 4. So it's going to be minus pi little r, and little r then was 4 squared. And then our little thickness of our slice is dx. So we've got that integral set up now, and the secret was not have a formula memorized, but look at the picture and figure out the area of this disk and then figure out the area of this hole. Okay, and then take the difference between those. Okay, let's go ahead and evaluate this integral. We can move the pi out in front. And then we have integrating from -1 to 1. We're going to go ahead and square this, so that's going to be 25. This would be minus 5x squared twice, so minus 10x squared, and then this would be squared would be plus x to the 4th, and then we factored the pi out, and this would be minus 16 dx. Now we can use a little fact here that could make this a little simpler. This is an even function, and when you integrate over a symmetric interval for an even function, it's equivalent to integrating from 0 to a. This is if we were integrated from -a to a. We can integrate from 0 to a and double it, because an even function is going to be reflected about the y-axis, so we can just figure it out from 0 up to the number, in this case up to 1, and then double it to get the other side, and that'll make it just a little bit easier to evaluate. So we're going to do that. So we're going to have 2 pi, and then we're going to work this integral, and these can combine to give us 9, so integrating that would be 9x, and then integrating -10x squared, that'd be -10 x to the 3rd, and integrating x to the 4th, that'd be plus 1/5 x to the 5th, and we would evaluate this from 0 to 1 then, because now we're doubling it, and then we would have the other piece. Okay, so that's going to make it easy to evaluate. Here we're going to have 9 minus 10/3 plus 1/5, and then we need to multiply that by 2 and pi. So we need to get a common denominator here and combine those and get 15ths. Looks like when we do that, We have 135 fifteenths minus 50 fifteenths plus 3 fifteenths. So our final answer is going to be 176 fifteenths pi.